right? So did you look? Were you able to see the different instruments that are being used, right? The different instruments that are being used in this practical setup. So we're saying the mass of the test tube is 13.21 grams. And I'm saying, remember this, right? Understand this. The practical procedure is always important. It is critical that we understand the practical procedure when carrying out experiments. Okay, so we're going to have, let's now proceed with our experiment. Let's push it a bit further. Right, let's push it a bit further. Okay. Right, let's place, let's continue. Okay, so now there's a substance that is now being added, There's a substance that is being added to the test tube. That substance that is being added to this test tube, let us observe. You can even pause. You are allowed to pause the video whenever you want, right? So observe the color that is in this test tube. Observe the color that is in this test tube. What is the color of this substance? I'm sure you are able to observe the color. I hope you're not using a black and white cell phone. Are there black and white cell phones? I hope you're not using a black and white cell phone and you're able to see the color of the substance. This is the copper carbonate that is in this test tube. That is the copper carbonate. And that is the mass now of the copper carbonate. 1.2 grams of copper carbonate. Because he is now simply now we have recorded the mass of the copper carbonate. Again, I'll re-emphasize, go back, T-A-R-I-N-G, tag. Okay, so now, because the decomposition reaction we're talking about right now is for copper carbonate, it's thermal decomposition. It is known as a thermal decomposition reaction. A thermal decomposition reaction is a reaction in which heat is applied. If you remember, just before you guys left, we had talked about exothermic reactions and we also talked about endothermic reactions. And a reaction in which the substances absorb heat, such as this one, because this copper carbonate is going to absorb heat and it's going to break down, right? It's going to break down into different substances. And because it is absorbing heat, therefore, this reaction is, guess, is it exothermic or is it endothermic? Which one is it? It is endothermic. It is endothermic. I know you got it. I know you got it wherever it is you're sitting right there. Dalikan, I'm sure you got it because you remember I showed you guys endothermic reactions. Martha, my dear, I'm sure you know it because I showed you an exothermic reaction when the fuel went boom. But now this is a decomposition reaction. There are no explosions because now heat is being absorbed. Okay, heat is being absorbed. So an endothermic reaction is taking place. Chimepewa, I hope you're also watching. I hope you guys are all watching from wherever you are. We miss you guys, right? I don't know, I keep on saying this because it's there in my hand. Okay, so now let's continue. So what's going to happen here is that this is a Bunsen band. This is a Bunsen band, okay? Let's identify, this is what we call a Bunsen band. It is connected to a source of gas and then it produces a flame. It is this flame which we use to burn the copper carbonate, okay, to heat it up to a point where we can disintegrate the copper carbonate. Disintegration, big words, not so big, but maybe big for others. But I know for you guys, they're not big words because you understand this stuff, okay? So what's happening now is that you start heating your copper carbonate, right? So you're placing the test tube onto the flame. Observe that sometimes we'll use glass, right? That is fortified glass that is strong, right? Which allows you to heat the test tube directly. It's almost as if the copper carbonate is already becoming a liquid, but it's not necessarily becoming a liquid. That is simply a gas being evolved, right? Because as you burn it, you find that there's a black substance that is produced. Observe. I'm sure you can see the colors. There is a black substance that is this is a black powdery substance that is being produced. But also at the same time, there's a gas that is being evolved. Right? There's a gas that is being evolved. When you write the equation, you will find that you will say copper carbonate. Okay, I'm going to give you this equation. Because it's copper carbonate, it disintegrates and it breaks down and it gives us the copper. the copper remains on its own, right? And then the carbonate part, the formula will be CO3. It disintegrates and it gives off carbon dioxide. And it gives off carbon dioxide. It gives off carbon dioxide. So now, I am sure you guys know the test. I am sure you guys know the test for carbon dioxide. How do we test for carbon dioxide? I hope ever you remember, right? I hope you remember, even you, Gabriel. Remember we did it last year when we looked at how we would test for different gases that are there in the atmosphere. I remember we said for oxygen, we would use a glowing splint, and then if we put it into a test tube that has oxygen, then it relights the glowing splint. What about for carbon dioxide? There's a substance that we say we use. We use lime water. I'm sure you guys know this. We use lime water. We take the carbon dioxide, we make a setup where we bubble the carbon dioxide into the lime water, and you will see the lime water changes from what? To what? Yeah, it does. It changes from clear, right? It will be colorless, then it changes to cloudy white. That is the change that takes place if you are having carbon dioxide being bubbled into lime water, right? So at this point, right, you will find that you proceed with the experiment, right? So you have effectively reached the end of the experiment. We are now reaching the end of the experiment because now we have been able to see the product, to see the color of the product. It's almost black substance, right? A black substance, a black powder remains. Initially, what was the color? You saw the color. You can rewind the video, you can go back and you can see the color. So write the initial color in your exercise. You will find that you have to write the initial color of what the copper carbonate was, and then the final color. I hope you'll be able to see this, right? So there we would end this particular experiment. Okay, so on your notes, you'll find that there's also an equation for calcium carbonate, the decomposition of calcium carbonate. I just put it there to help you guys, because I need you guys to be familiar with as many decomposition reactions as possible. Okay, then another substance that we talk about when we're talking about decomposition reactions is copper sulfate. Copper sulfate. Why copper sulfate? Copper sulfate is an important substance because I hope you know what it is used for. If you have been reading your notes, if you have been going through your textbooks, you would have found out that copper sulfate is used to test for the presence of water. Okay, so if you have a liquid, okay, if there is a liquid and we do not know what that liquid, if that liquid contains water on it, what we simply do is we take copper sulfate. It's a white powder. Copper sulfate, anhydrous copper sulfate, which means that it doesn't have water, is a white powder. Okay, it's a white powder. But then, when it is in the presence of a liquid that has water in it, it changes to a blue substance. Okay, so anhydrous copper sulfate is a white powder, and then when it's in the presence of a liquid that has water in it, H2O, water. I'm sure we all know water, rainwater, the water that we drink. Okay, if it's in the presence of a liquid that has water, then it will change to the color blue. Then it's now called a hydrous or hydrated copper sulfate. Hydrated copper sulfate. Hydrated copper sulfate. So when it doesn't have water in it, it's called anhydrous copper sulfate, and its color is white. When it has now been exposed to a substance that has water, then it changes to blue, and it is then known as, it's known as what? Yes, it's known as hydrated copper sulfate. Okay, so as we now approach the end of this lesson, this is basically it on decomposition reactions. So what you guys are going to do is, okay, you are going to write an exercise, just a small exercise, just a small task for this lesson. Okay, at the end of the second lesson, you'll find that I will give you a full exercise. But right now, I just want you to do this task where you write the word equation for the following decompositions. I want you to write the equation for the decomposition of calcium carbonate, decomposition of calcium carbonate, the decomposition of ammonium carbonate, the decomposition of ammonium carbonate. Then I also want to write the equation, the word equation, just write word equations. The word equation for the decomposition of hydrated copper sulfate. Decomposition of hydrated copper sulfate. That's what I need you guys to do. So what have we looked at today? Today we were able to look at the definition of the term decomposition, right? I'm sure by now you have now understood what decomposition is. Also, just give yourself the chance. It's a video recording. You can rewind it, you can pause it, you can watch it as many times as you want. You can watch it as many times as you want. Do not feel restricted. So you can go back, you can then ask yourself, okay, so what was the definition? What did he say was the definition of a decomposition reaction, ELO? You go back, you look again, you look again, you look again. Okay, so we looked at the definition, right? We looked at the practical experiment, and I'm hoping that you're now able to describe what you would do if you were asked to say, how would you carry out the decomposition of copper carbonate? You would tell them, okay, I'll take a test tube, I place the copper carbonate inside, and then I hit it, I bend it, and then it breaks apart. You explain all of those things. You are now able to do all of those things, right? So then you should also be able to state the observations. So when you're writing the practical, make sure you fill in the spaces that are there on the document. So when you're filling in, right, you will be able now to see, okay, so these are the observations, and what conclusions can you draw from this particular experiment. Okay, so in the next lesson, this lesson was on decomposition reaction. In the next lesson, we will look at synthesis reactions. That was decomposition, breaking down. Synthesis, the opposite now of decomposition. What is synthesis? I'm sure we'll talk about that in the next lesson. Okay, so this is Marshall Candiado, your science teacher. I miss you guys, I love you guys. I'll see you in the next lesson. Thank you.